This video is part of the project Widening Indigenous Participation in Higher Education through Strategic Partnerships. It's supported by the Department of Education HEPPP Partnership Project Funds. This is a video for the measurement section of the Mathematics 2 General Course, Measurement MM4. This video will demonstrate area, Simpson's rule, surface area and volume. Question 1. Find the area of the following semicircle, correct to 1 decimal place. As a semicircle is half a circle, then the formula for the area of a circle must be halved. Since we are given the radius, substitute the value of 5 for the radius into that formula. Use your calculator to get an answer and then round it correct to 1 decimal place to 39.3 centimetres squared. Alternatively, you could calculate the area of the whole circle first and then halve your answer. Question 2. Use Simpson's rule to find an approximation for the area of this field. Give your answer to the nearest whole number. Simpson's rule gives an approximation to area. The formula from the formula sheet is A is approximately equal to h on 3 times the first distance plus 4 times the middle distance plus the last distance. The h is the equal distance between the measurements. In this case, it's 60. Then when we look at our diagram, the first number is 60, the middle one is 47, and the last one is 41. Substitute these values into the formula and use your calculator to evaluate it. When you're finished, round it off to the nearest whole number and you should get 5,780 square metres. The answer is not exact as Simpson's rule only gives an approximation. Question 3. Find the surface area of the following closed cylinder, correct to 1 decimal place. So check the formula sheet for the correct formula. As the cylinder is closed, there are 2 parts to the formula. The first part you see here is the area of the 2 circular ends. The second part, 2 pi RH, is the area of the curved surface area. If you think about the cylinder as a can with a label on it, the curved surface area is the label and the 2 circles are the 2 ends of the can. The radius is 7.9 metres and the perpendicular height is 8.4 metres. Substitute those numbers into the formula and use your calculator to evaluate it. When you get your answer, you need to round it correctly to 1 decimal place. In this case, it is 809.1 square metres. Question 4. Find the surface area of a sphere with radius 6 metres, correct to 2 significant figures. The formula for surface area is surface area equals 4 pi r squared. Remember that the units for surface area are square units. Substitute the value of the radius, which is 6, into the formula and calculate. When you do that, you get 452.3893421. This must be rounded to 2 significant figures, which is different to 2 decimal places. To round it to 2 significant figures, starting at the left side of the number, take the first 2 non-zero digits, which are 4 and 5. Those are all the digits you're going to use. So you're going to have 4, 5. Because it's 452, we're going to write 450 as our rounded to 2 significant figures answer. Question 5. Find the volume of the following solid. The solid is a rectangular prism. Previously, you would have learned the formula for a rectangular prism. You multiply the length times the breadth times the height. But the general formula for a volume of a solid with a regular cross-section is volume equals area of the base times the height. We're going to use this approach to find the volume of this solid. So the base and the uniform cross-section are the same. That is, it's a rectangle 10 by 13. The perpendicular height then is 9. So we're going to multiply 10 by 13 for our base and multiply that by 9, the height. That gives us a volume of 1,170 centimetres cubed, or cubic centimetres. Question 6. Find the volume of the following composite solid correct to the nearest whole number. In this case, the cross-section is a rectangle and a triangle. So we need to find the area of the rectangle and the triangle first. The area of a rectangle is length times breadth, so that will be 57 times 33. The triangle has a height of 28 and a base of 57, so use those numbers to calculate the area of the triangle. That gives us the area of the rectangle and triangle to be 2,679 square millimetres. We can now find the volume of the prism by multiplying that area of that base by the perpendicular height, which is 21. Multiplying those together gives us 56,259 cubic millimetres. Remember, volume is in cubic units. So when I say please pause the video as each question comes onto the screen and complete the answer, then restart the video to see the solution, then repeat that process for each question. There are 5 questions based on these examples that have been provided. Question 1. Please pause the video now. In this question, you were given the diameter, not the radius. So we have to halve the 18 to get the radius of 9. Once we have that, it's a semicircle, so we've got to use half of the area of a circle formula. Substituting those values in gives us the answer of 127.23 square centimetres to 2 decimal places. Question 2. Pause the video now. In this case, Simpson's rule needs to be applied twice. The value of h is 6, and we calculate it twice using, firstly, 19 as the first, 14 as the middle, and 5 as the last. Then for the second piece, we use 5 as the first, 9 as the middle, and 10 as the last. Substituting those values into the formula gives us the total area of 262 square metres. Question 3. Pause the video now. Since the diameter is given, we need to halve that to find the radius. So the radius will be half of 11.3, 5.65. The height is 12.7. Taking the formula from the formula sheet and substituting in those values will give us our answer of 651.4 square centimetres. Question 4. Pause the video now. Using the surface area of the sphere formula, we need to have the radius. Since the diameter is given, we divide it by 2 to calculate the radius. That gives us 6.5 for the radius. Substitute that value into the formula and calculate. Then round it off to 2 significant figures. Again, take the first 2 non-zero digits from the left-hand side, which is a 5 and a 3, and then add zeros until you reach the decimal point. So you have 530 square millimetres. Remember, surface area is in square units. Question 5. Pause the video now. The base is a triangle, so calculate the area of a triangle by multiplying it by a half base times height. In this case, a half times 10.4 times 7.8. Then to find the volume, we multiply by the perpendicular height, which is 6.1. This gives us a volume of 247.416 cubic centimetres. Remember, the units for volume are cubic units. There are now another set of questions. So pause the video after each question and the next slide will show the solution. It will just show the solution without any audio. Use the area of a circle formula in this case, but multiply by a fraction with 360 in the denominator to find the area of that sector. Pause the video now. Question 2. In this case, use Simpson's rule above and below the middle line, with 50 as being the value of h, and one of our values for the distances will be 0. Pause the video now. Simpson's rule is used twice, with 71, 109 and 33 as our distances, and in the second case 48, 12 and 0 as our distances. Question 3. Pause the video now. Because it's an open cylinder, we only use 2 pi RH. In other words, we're only finding the label in this case, not the entire closed cylinder surface area. Question 4. Remember that the volume of a pyramid is 1/3 the area of the base times the height. Pause the video now. The base is a square, 8 by 8, and the perpendicular height is 13. Remember, as it's a pyramid, you need to do 1/3 times the area of the base times the height. Question 5. Pause the video now. To find the area of the base, you need to find the area of the rectangle and the semicircle. Once you've done that and found the total for that, then you multiply by the perpendicular height, which is 12. Adding those two together gives the answer. This concludes the video, and the video is part of the project Widening Indigenous Participation in Higher Education through Strategic Partnerships, supported by the Department of Education HEPPP Partnership Project Funds. Thank you.